Greetings, Professor. Here is our final project, crime trend analysis. We have taken a crime data set and we have done different types of analysis for that. And here are team members, myself Vaishnavi and other team member is Suhas. Here is our abstract. These data sets include historical crime data from different metropolitan areas and what are the temporal patterns occurred, what are the long-term trends occurred, and we have done analysis based on the crime trends based on daily, weekly, monthly, and yearly variations, and what are the different types of crime patterns over multiple years, what are the different shifts occurred, etc. Here is our data set. This data set is a record of reported crimes in metropolitan areas, including details such as location, date occurred, time occurred, uh, victims, age, sex, and descent. What are the weapons used? What's the case status? What is the latitude, longitude, street address, cross street, and etc. Here are the columns included in the data set. Division of record number, date, repeated date occurred, time occurred, area name, reporting district number, crime code description, victim age, victim sex, victim descent, premise code description, weapons used, weapon description, status, case status description, location, cross street, latitude, and longitude. And coming to the end goals of the project, we analyze the seasonal variation in crime rates and identify any recurring patterns with specific seasons and holidays. Next, we have identified temporal patterns in reporting crimes over time, including daily, weekly, monthly, and yearly trends. Next, we have investigated the long-term trends in crime rates over multiple years. Next, we have done the comparative analysis of crime trends across different geographical areas with higher and lower crime rates. Uh, Focusing on the comparison of the victim sex ratio and age group distribution across different areas and over time. Next, we have developed a predictive model to forecast future crime trends based on the historical data and contextual factors. So we have uploaded the data. We have used Panda module. Here is the path for our drive link. We have displayed the data set. We have printed the length of the data set. We have printed the columns of the data set. Then we have performed the data cleaning, which include various steps to ensure the data has a quality and integrity before going for the further analysis. Next, we have done handling missing values. Missing values are when we found out columns with missing values and contain entirely null values. So we have done this process and we have printed the length again. We have displayed the final data frame. Now here we have done the seasonal and monthly crime trends. We have done the geospatial analysis. This is the geospatial analysis. The data set includes latitude and longitude column, which contain geospatial coordinates for each time. And we have done the decomposing date. So the date occurred column in data set provides valuable temporary information. So we have decomposed the date occurred into date time. Then we have segregated the date time into years and months, and then we have segregated years and months into seasons. So here is the code for that. So after running the code, this is the crime counts by season bar graph. This is the crime counts by month bar graph. So comparing with crime counts by season bar graphs, we have 4 seasons. This is number of crimes occurred in each season. When we look at the graph, we see that the crime count has been gradually increased in the winter season. There are more in the winter season. And coming to the crime counts by month, here is the number of crimes occurred and these are the months. Comparatively, among all months, we have January month with higher crime rates as it's a festive season. So January month have the most of the crime rates occurred. And this is the description for the crime counts by season, crime counts by month. So seasons have 4 seasons and months 12 months. And next we have done time series aggregation for analysis. Here we have taken the date occurred and converted that to date and time, and we have segregated that to daily, weekly, monthly, and yearly. So an analysis based on daily, weekly, and monthly, yearly patterns are done here. So this is the code for that. And we have different graphs for daily, weekly, monthly, and yearly. This is the daily crime count graph. We have number of crimes and we have crimes over years, like from 2020 to 2024. The data set is from 2020 to 2024 So when we look at the graph, daily crime counts has been gradually increased in 2020, and it has been decreased in 2024 between the fluctuations. And we when we see the weekly crime counts from same 2020 to 2024, it has been increased in 2020, and it has been more increased in 2023, and then gradually decreased in 2024. Monthly crime counts. So coming to the monthly crime counts, same from year 2020 to 2024, the crime counts have been gradually decreased, and it has been more in 2022. And this is the description for the daily crime counts, weekly crime counts, monthly crime counts. And we have done analysis of yearly crime trends and rates, and this is the code for that. So here is the line graph for the yearly crime trends, number of reported crimes and in which year. So in 2020 they have been high, and in 2022 it has gone to peaks, and in 2024 it is gradually decreased now. And this is the explanation for yearly crime trends, and we have displayed the columns again. We have included year, month and seasons here. And coming to the crime trends by area over years, based on the areas we have done the analysis, this is the code for that. And this is the multi-line graph for crime trends by area over year. We have different areas, different years, and number of crimes occurred. So this same from 2020 to 2024, these are the years, these are multiple areas, and we see that there is a gradual increase in 2022 in crime, and now we can see a gradual decrease in 2024. So this is the multi-line graph explanation for crime trends by area. The next part will be continued by my next team member. Thank you.
Greetings, I'm Suhas Managanti. I'll continue further. We are now comparing victim-sex ratio. As per the dataset, we are dividing the victims into male, female, and non-binary. So as we can see in the code, we are plotting a pie chart and a bar graph for the given data. The pie chart depicts that the 41% of the male victims are present, the remaining are female and non-binary as 22.3%. Also, the bar graph depicts male, female, or non-binary over a range of 0.0 to 0.40 percentages. Now, we see it across the years. We have divided the male, female, and non-binaries victim ratio across the years as per the code. As we can see, the ratio has been dropping accordingly for the male, whereas for non-binary, it has been increasing over the years of 2022 to 24. And the female ratio has trends varying from year to year. That is from 2020 to 2021, it's been a little rise, and after from 2021 to 2022, we can see there is a sharp rise of cases, and later on it's been decreasing a lot. So, victim and sex ratio across different areas in a particular area is been also calculated with the help of graphs. We have grouped the area names with the victim sex ratio and years. As we can see in the graph, the purple represents the female, the sign represents the male, and X represents the non-binary category. And also, we can take a trend of areas with respect to their genders and over the years. So we can see that considering certain areas such as Southwest and Howlenbeck and Harbour, we can see there is a steep change in the male victims. As we can see, there are more non-binary victims in the areas of Harbour and Howlenbeck compared to Southeast, where it has minimum non-binary victims and maximum male victims. The ratio of female victims all over the places are almost on an average path. And also, we can segregate victims into age buckets: the seniors, the adults, the youth, and the children. As plotted by the code, we can see that 41% of the adults are victims, the 21% are the youth, the 8.5% are the seniors, and 28.4% are the children. And when we take an account of number of victims, we can see that every year it's almost ranging to 200,000. And mostly in the year of 2023 and 2022, it has peak rise more than 200,000. As 2024 is not calculated yet, we got to have more information about that soon. And when we distribute our age categories by location and the number of victims, this is how the chart goes. The central has a maximum of 60,000 victims. The minimum victims are from Foothill, and the average victims range from 35,000. The geographical distribution stack graph shows the following information. Now we are moving to model training and test for prediction. Here we split the data from the data set into training data set and testing data set, such that after training we can compare the data with the remaining data with the testing data set to get a proper result. Here we do data pre-processing using certain modules like scset learn and memory optimization blocking. The main feature here we are using is called a random forest. It is a model used for prediction of future data. It is a simple combination of graphs using algorithms to get an accurate prediction. The testing and training of the model is shown here. We have divided the data into chunks and trained the model as GPU is not sufficient in the collab. Here we are predicting the status of case for future. We are providing sample test data and the status of the data is also predicted. The feature engineering and model data preparation block has a column. The date RPTD is converted to a data time object for time series analysis, which was mentioned earlier. A random sample constituting of 10% of data is then extracted to create more manageable data set for training and testing from the data. As the date memory won't fit all at once, we had to make it into chunks and run one by one. So this would be beneficial for the course not to take load and shut down the collab or not to exceed memory. The model training and evaluation block is dedicated building machine learning model. Here we use the random forest classifier, which is used to give accurate and more precise outputs. The memory cleanup block is used to clean up the memory to reduce the space and save the RAM at the particular time. We use gc.collect, which triggers explicit garbage collection to free memory from unreferenced objects. As you can see, the model for code, this is the data which we load in chunks and iterate over each chunk. These chunks are executed separately to get the reliable output and to train the model in a particular way. After training, we get a precision of 0.27 and 23, and when we recall it, we get of 0.03 and 03 and each time. The accuracy macro average, weighted average, is 0.70, 0.80, and 0.73 in the following. The sample prediction for the test cases, the pre-trained machine learning model is now applied to a small formatted data set which has been extracted from the data set for the training purpose. The input features consist of year, month, location, coordinates, and victim's age, as mentioned in the bar graph above, which we have seen for the age, gender, area, and number of victims. The model's predict function is used to estimate the likely status for each sample. The concise results offer a snapshot of model's capability to generalize new data. After prediction, we can see a prediction status each time. And finally, for the results and conclusion, the above model shows a distinct patterns of seasons and months and trends of crime data, which has been analyzed and studied deeply to provide a geospatial analysis highlighted in significant disparities in the crime rates among the different geographical areas. Additionally, the demographic insights into victims, particularly gender composition and the age, are a valuable context for this project. Our future directions would be data augmentation and real-time monitoring. As we can get the real-time data very quicker with the new latest technologies, we want to make our project a real-time data such that it updates dynamically each and every time through a website or an application. And also the advanced technologies could be used to reduce the load on the processor and simplify the course such that we can get more accurate results in the upcoming future. The longitudinal studies conducting the longitudinal studies to evaluate the efficiency of crime prevention and initiatives over time. This data would help in predicting the number of crimes which might be possible and decreasing the trends on an yearly scale. So here are references for our documentation and data source URLs. Thank you.